As is well known to this audience, prematurity remains a major public health issue. Preterm birth complicates 10% of all pregnancies, with 65 to 75% occurring spontaneously. A failure to understand causes of preterm birth has significantly limited development of effective interventions. So what's new in the field? Small studies have demonstrated a potential association between vaginal microbiota and preterm birth. In the largest study to date, our group recently demonstrated in a cohort of predominantly non-Hispanic Black women that a non-optimal vaginal microbiota and specific bacterial taxa were strongly associated with spontaneous preterm birth. Describing the microbiota as optimal and non-optimal is a reductionist approach to study how the microbiota and different biologic systems might be associated with health and disease. For the vaginal microbiota, in 2011, Ravel and colleagues first described a hierarchical clustering scheme to classify cervicovaginal microbiota into 5 community state types, or CSTs, based on predominating bacteria. CST classification has been used to study health and disease in both non-pregnant and pregnant women on an international scale. As an example, CST4 is this rightmost cluster shown here that has a distinct set of bacteria present compared to the other communities. With respect to the composition of these 5 communities, CST1, 2, 3, and 5 are dominated by 1 to 4 lactobacillus species, while CST4 comprises an array of strict and facultative anaerobes and a relative lower proportion of lactobacillus. CST4 is this non-optimal community demonstrated to confer an increased risk of spontaneous preterm birth. While a non-optimal microbiota has been linked to preterm birth, we know that spontaneous preterm birth is a complex, multifactorial disorder with many contributing factors. Specifically, maternal stress is posited as a driver of spontaneous preterm birth. Overwhelmingly, the largest risk factor is a history of prior spontaneous preterm birth. To date, no study has interrogated molecular biomarkers, specifically the vaginal microbiota, with stress to examine their combined impact on recurrence of spontaneous preterm birth. We hypothesize that maternal stress and a non-optimal microbiota will be associated with spontaneous preterm birth in women with a prior preterm birth. Based on our hypotheses, the objectives of our study were: 1, to determine the independent effects of perceived stress in CST4 on the odds of recurrent spontaneous preterm birth. 2, to determine whether high perceived stress and CST4 were associated with one another. And 3, to determine whether a combination of high perceived stress and CST4 increased the odds of recurrent spontaneous preterm birth. This was a secondary analysis of a prospective cohort entitled Motherhood and Microbiome, in which 2,000 pregnant women were enrolled. Here's a flow diagram of our pregnancy cohort. 2,000 women enrolled in the parent study. After loss to follow-up and exclusions for medically indicated preterm birth, there were 1,836 women remaining, of whom 201 had a history of spontaneous preterm birth. 90% of these women had stress measurements, providing 181 women to query the association between stress and recurrent spontaneous preterm birth. And of those remaining 181 women, 74 also had cervicovaginal microbiota data. Perceived maternal stress was measured using the Cohen Perceived Stress Scale, or PSS-14, a validated stress assessment questionnaire. The survey was completed between 16 to 20 weeks of gestation. Based on published literature, a PSS-14 score of greater than or equal to 30 was considered high perceived stress. Cervicovaginal swabs were also collected between 16 to 20 weeks of gestation. Microbiota were analyzed using 16S ribosomal RNA gene sequencing as previously described, and were classified into CSTs by hierarchical clustering. The vaginal microbiota was dichotomized by optimal and non-optimal. History of preterm birth and cases of preterm birth were individually adjudicated by a maternal fetal medicine physician to determine whether spontaneous or medically indicated. Preterm birth was considered spontaneous if a woman presented with either cervical dilation and/or PPROM and delivered prior to 37 weeks of gestation. Women with medically indicated preterm birth were excluded from this analysis. We performed bivariate analyses evaluating the associations of high stress, CST4, and recurrent spontaneous preterm birth. Multivariable logistic regression was used to model adjusted associations. Confounders were retained in the adjusted models if they altered the effect estimate by more than 10%. Given that race is highly correlated with cervicovaginal microbiota, we also performed sub-analyses restricted to non-Hispanic Black women who comprise the majority of the cohort. Finally, we explored whether there was the multiplicative interaction or additive effect of high stress in CST4 on the outcome of recurrent spontaneous preterm birth. To perform the latter, we created a 4-level variable of the 4 possible combinations of stress and CST classification. Here are our results. This table presents the demographic characteristics of women with a history of spontaneous preterm birth who did or did not have recurrent spontaneous preterm birth. The majority of women were non-Hispanic Black. The groups were similar in regards to age, race, BMI, and marital status. Women with recurrent spontaneous preterm birth were more likely to have a short cervix compared to those with term birth. In regard to the results for our first objective, we did not detect a significant difference in the proportion of women with high perceived stress who went on to recurrent spontaneous preterm birth versus term birth. The blue portion of the bars represent low stress, while the red represents high stress. 31% of women with recurrent spontaneous preterm birth had high perceived stress, while 23% of women with term birth had high perceived stress. In adjusted models, we did not detect a significant difference in the odds of recurrent spontaneous preterm birth among women with high versus low perceived stress. When we restricted to the 146 non-Hispanic Black women, the odds ratio was similar. We next looked at the prevalence of CST4 and birth outcome. The blue portion of the bars represents non-CST4, or an optimal microbiota, while the red portion of the bars represents CST4, or a non-optimal microbiota. A higher proportion of women with CST4 had recurrent spontaneous preterm birth versus term birth. Specifically, among the women who went on to recurrent spontaneous preterm birth, 51% had CST4, compared to only 28% of women who went on to term birth. This was significant with a p-value of 0.04. In logistic regression models adjusted for race and marital status, CST4 was associated with a 3.6-fold increase in the odds of recurrent spontaneous preterm birth. The adjusted odds ratio was similar when restricting to the 64 non-Hispanic and Black women. Next, our second objective. We examined the relationship between perceived stress and cervicovaginal microbiota. 38% of women with low stress had CST4, while 42% of women with high stress had CST4. This difference was not significant. Furthermore, in adjusted models, we did not detect a significant association between the odds of CST4 and high versus low perceived stress. We also did not detect a significant interaction between perceived stress and CST4 on the outcome of recurrent spontaneous preterm birth, with a p-value of 0.33. On to our last objective. While we did not detect a multiplicative interaction between perceived stress and CST, we created a 4-level variable to look at combinations of stress and cervicovaginal microbiota states on birth outcome to address our hypothesis that more than one exposure may increase the odds of recurrent spontaneous preterm birth additively. The odds of recurrent spontaneous preterm birth among women with high stress and CST4 was 6-fold higher compared to women with neither factor. The increase in odds was primarily driven by the association with CST4, as both women with high and low stress had increased odds of recurrent spontaneous preterm birth if they had CST4. Key findings from our study are notable for the following. We did not detect a difference in perceived stress among women who went on to recurrent spontaneous preterm birth versus term birth. However, as demonstrated by wide confidence intervals, we were likely underpowered to detect an association. We demonstrate that CST4, a microbiota enriched in anaerobes and relatively devoid of lactobacillus, is associated with a 3.6-fold increased odds of recurrent spontaneous preterm birth. In this study, we did not detect an interaction between stress and cervicovaginal microbiota. Strengths of this study include its prospective enrollment with multiple covariates allowing for assessment of confounding, in addition to assessment of exposures early in the second trimester. The study contains a large proportion of non-Hispanic Black participants who comprise a population at increased risk of spontaneous preterm birth. With respect to limitations, this is a single-center study, and as such, there may be limited generalizability. Furthermore, assessments of perceived maternal stress and cervicovaginal microbiota were performed concurrently, thus precluding investigation of temporality or causality. However, the pregnancy study was prospective, and these exposures were collected prior to the outcome of recurrent spontaneous preterm birth, suggesting that these variables may play a role in birth outcome. In conclusion, in a predominantly non-Hispanic Black cohort of women, a non-optimal cervicovaginal microbiota is associated with increased odds of recurrent spontaneous preterm birth. For further insight into potential mechanism, please see our presentations and join us for the remaining poster session this afternoon. I'd like to acknowledge my collaborators, mentors, and the Maternal Child Health Research Center. Thank you for your attention, and I'd be happy to take your questions.
Great job, Kristin.